Hello everyone, and in this video today, we will continue with our series with a new topic, and which is dynamic operators, DOPs. And in this video, I will cover the very basics of the DOPs first. I will cover what are DOPs and how it works, what they do, and how we can create a small setup to create our first simulation. And in this video, as ever, I created the notes. Also I have created a PDF of everything that we will learn in this video. And this PDF is necessary because now videos are getting more technical and we need some notes to understand the theory like behind these nodes and networks. So you can download the PDF, the link in the description. And let's now start with the video. But first, I want to tell you what I will cover in this video. And I will cover first what is DOP. Second, inside that, we need three elements. First, object. Second, source. Third, solver. And I will cover each of these. And let's just start the video. So you see here, I have some notes for you, and I have this simple setup. Here we have our DOPnet node, and this DOPnet node is lives in the SOP level. This is a SOP level node. It is living at the surface operators right now, and inside this, every node here is DOPs. They are dynamic operators. I will cover this, but first, let's create a simple fog volume so we can have something to work on, right? I have created a box and just create a box and VDB from polygons, right? Just I have scaled it and made it a bit flat, and I have add this VDB from fog, and you can see it is easy because we were working with volumes in the last video, so you know how to create this, and it's very easy to create. And now this DOPnet dot, which is DOP import DOP network, and this DOP network is a gate to the dynamic operators. See it as a gate. It is at the SOP level that are surface operators that creates or modifies the geometry, right? It is also modifying the geometry, and here the geometry this is also a geometry. The volume here is the geometry. Geometry is not only the primitives, polygons. Here, this is a volume geometry. And the smallest unit here are voxels, right? We know about this. Okay, we have DOPnet. DOPnet is our gate to the dynamic operators. And what are dynamic operators? So the DOP nodes let us do the simulation work. Everything we do, like whatever we are doing in the simulation part, is done by the DOP's dynamic operators. And here, a really good thing, I've created the nodes also, and I have added how it is different than the other nodes. Dynamic operators, everything we simulate. Simulate means here like how the data, how the values change or evolve over time. If I have a density, and this density value keep on increasing over time. How we can do that? We can do that by the dynamic operators. Here, a very common misconception. Here, you would say we have this VDB from particles, and we can increase or decrease the density of this fog volume, right? We can increase or decrease the density of this fog volume, but here I want to make something clear. The density here lives at the SOP level, and the density we simulate would be inside this DOP network. And I want to make something clear here that at the SOP level, the simulation is not happening. We are just changing the value. Simulation, how simulation happens? I already said that the density value is evolving or changing over time, right? So let's say frame 2 is dependent on frame 1. So let's say you have this density value and you are saying that with each frame I want minus zero point 0.1 density, right? I want minus 0.1 density. So every frame we are removing zero point 0.1 unit, like 0.1 unit from the density. So here, how it is different from the this VOP level when we change the density, how it is different, how simulation is different when we at the SOP level and we are changing the values of density. What is happening here is like this node, when we change the density and we get a value, right? So every frame we getting a value. Second frame is not like asking for the first frame values. We call that stateless evaluation. The case when we animate the noise over time in the volume noise fog. Let me give you an example. I have this sphere. Try to understand what I'm saying. We have this. What if I increase or decrease the amplitude? We are on the first frame. I'm saying at this frame I want the amplitude to be 5. Now what is happening here? It is reading the value. It is only reading the value. It is not simulating, it's just reading the value. I'm saying I am on frame 2 and I want the values, let's say 6. Frame 2, the value is 6. It is just reading the value. And what is happening here? When I'm moving with the frames, what is happening here? We see something, right? And we see this because at each frame, it is reading a value. It is not simulating, it is reading a value. And how it is reading value and why it is changing? Because we have this animation turned on in this volume noise fog. And how it is different? How it is different? It is just reading the values at each frame. It is just reading the values at each frame. We have this animation on. It is like reading the values. The values are changing, but it is reading at each frame. And how it is different? Let's say this. This is an example. The case when we animate the noise over time in the volume noise fog uses noise values plus time. Does not use last frame density. It is not like evolving. It is not evolving or it is not the values are not decreasing. They are just, it is just reading the values at that frame. It don't care how what are the values on the last frame. It doesn't care. It just need values and it would show you the result of the value. That's it. So here is, we call this stateless evaluation, and inside the DOP network, the time matters. The time matters, the frame matters, and the evaluation matters. And how? I have a note about this. A DOP network is used when time matters. If something changes over time, if something moves, falls, grows, collides, spreads, if the result at 10 frame depends on the frame 9. I'm saying I want this particle to go here, right? At 10th frame, I want this particle to be here. So I want to move this particle, and this particle will move frame by frame. Frame 1, frame 2, frame 3, frame 4, frame 5. So this frame 10 needs a value from frame 9. The frame 9 values matter to this frame 10. That's how it is evolving. We can put the values in the SOP that I want this value, this value at this frame I want this value, at this frame I want this value. but it won't simulate. It won't simulate. This is just a simple example. When we have like temperature, velocity, right, density, and we are advection, like we have advection, we are advecting, uh, advecting the density values towards through the velocity. We need simulation. We cannot like read those values. How we can like advect something? We need simulation, right? That's what DOP network do. Okay, I have this example also when I said that how this is a geometry. I have this note for that. A VDB is a volume geometry, not surface geo. X means not because it is stored as a SOP primitive. This container is a primitive, right? And inside this we have volume voxels, and but it represents volumetric data rather than a surface. Surface is a geometry. Volumetric data is also a geometry, also a type of geometry. Okay, now let's read these notes. Surface operators. Works on geometry, creates, modifies geometry, right? And vex operators. Attribute is a SOP node. First, attribute is a SOP node. Inside attribute VOP, I meant attribute VOP is a SOP node. Inside this, we use VOP nodes, math noise option. So inside that, we were writing vex, but through nodes, right? Okay. DOP dynamic operators. This is what we want to talk about. A DOP node is not about geo first. A DOP node is about time, state, physics, rules, solving over frames. DOP node describe how something behaves over time. If I am saying this water, I have water, and I'm saying I want to like boil this water. So the particles, the water molecules that are below this container would get like warmer, would get hot with time, and when like these warmer molecules will get at the top because of the, let's say, buoyancy, right? That's why we need simulation here. We cannot just say I want this particle here, 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 because it is very complex if we uh, like read the values per frame. So we need simulation here, like the real time physics. So DOP node is not about geo first. DOP node is about time, state, physics, rules, solving frames over time. DOP nodes describe how something behaves over time. A DOP network is a SOP level container. This is our great through the dynamic operators whose only job is to run whose its only job is to run physics simulation inside it. That's it. SOP is static, no memory. Dynamic has memory. Each frame wants to know what the values or what the geometry, what it like its behavior on the previous frame. We need this. You will understand this better when we move with this video. DOP main insight. Remember this: geoparticles are created in SOPs, and physics simulation happen inside the DOP network. The simulation updates the state. That state is then converted back to the geometry, and we convert back to the geometry by the output node. I will come back to this also. DOPs decide how those shapes behave over time, like how those shape evolves or change over time. In example, we only deciding how the data behaves over time. Just remember this. SOPs, we create the data. In DOPs, we evolve, we change the data over time. By how? By solvers. I will go back to this also. So object level DOP simulates thing. What happens if I create a DOP network here? DOP network is to simulate things, but here it would simulate the objects that are present here, right? And we don't need to do that. And here DOPnet is simulating the objects here, the attributes, the particles that exist here in the geometry at the geometry level. And let's move with the video. It's already I've explained a lot. So inside this I have this simple setup, and I will explain each node. But first let's talk about smoke object first. First, I want to tell you we need three things. We need three things. First, our object. Second, our data. Third, solver. How? Let's let me explain this. I have this smoke object sparse. We have we need an object. What is an object? Here we have empty object. We have this empty object. We see nothing. Okay. So what is this object? Object is a container that holds the data to simulate. How this container is different than this container. And I want to tell you something here. The real difference is simple. The container that we like store the density, let's say in this example, let's say density. The container that we store our density in the voxels is just storing the value. It's just storing the value. And here, this empty container will contain the same volumetric attribute, but here it is containing that data to simulate it. And we need different types of containers here. So this container is doing the simulation work here. And I want to tell you something here also. At the SOP level, we say volumetric attributes. The density there, the temperature there are volumetric attributes. But here we call those fields density field, temperature field, velocity field. And I have created a short note about this object and empty object and smoke object. This empty object contain no fields, none. It's empty. And smoke, for smoke we need some volumetric attributes, and here we call them fields. We need temperature, velocity, density. So we need those fields in this container to simulate it. And you will understand this with time. You will understand this. So let's, for example, what is the difference between this smoke object sparse container and this empty object? This smoke object is an empty object, but it has fields related to smoke simulation. Like let's see these parameters. This smoke object has fields, it has attributes, but those fields have value 0. Go to geometry spreadsheet and toggle this on. You would see smoke sparse 1, and we have these fields here. So when we change the values of these fields, we will get our simulation. But here we just have an empty container with these fields, but we need to have a data. We need to put the values in those fields, and we need the related field. We need the corresponding field. I will give you an example. But first, let's read this note. Sparse smoke object. What is this? Sparse smoke object, a container. It stores field like density, volume, temperature. And these fields, we call them volumetric attributes at the SOP level. But here, we call them fields because they are simulations. We simulate them. The data is the same, but the data is evolving, changing over time. We change or evolve that data. So we call them fields. Remember remember that we call the fields by this because we are changing, we are evolving that data over time. It does not simulate. Use VDB sparse volume because it is smoke object. So I have created a smoke object because I want to have a simulation based on smoke. We will do the velocity also. We will do the smoke fire also. But here I just need the smoke object, and we have every field we need to simulate a smoke. That's why it is like a shortcut to create the smoke simulation. it contains, like, it has every field we need, like velocity, density, and here you can see that there. And we have uses VDB sparse volume. It only uses sparse volume because sparse volume is like more convenient, more like memory friendly, right? Okay. Smoke object stores data. It does not change it. It stores data. And how we can change that data? It's just storing the data. We can change by the solver. I will uh, also get back to it. But first, empty object no fields, sparse smoke object predefined smoke fields like density, velocity, temperature, etc. How the simulation would happen? How the simulation would happen? I want to like I want to give you an example. If you want to simulate our smoke, let's say we want to simulate our smoke. This is 3D. These are like visuals, right? So how we cannot like simulate our data. We need something to have the gist of simulation, right? So here, what we do, voxels do not move, only values move. And when values move, we see the effect like we see in the real world. How? Voxels do not move, the grid stays fixed, only the values inside the voxel change. This is a really simple example I have created here. You see, frame 1 density, we have these voxels. Let's say voxel 1, voxel 2, voxel 3, voxel 4, and we have the density value. You see, frame 1 density is something like this, frame 2 density. In those voxels, we have 0, 1. In those voxels, we have, like, the density is shifting. We have two voxels, so the density is shifting. Here, voxels is not shifting. Values is getting changed, and we see like moving effect of this fog. Right? You understand what I'm saying, right? I guess you understand that. Frame 1 density, these voxels have 0. You see, the values are shifting, and we like see like it is moving, but it is not moving. The values are changing. Why smoke object? We already had the primitive we related. Okay, like the thing I like told you before, how this container is different than the volume container. We have the data. Why smoke object when we already had the volume primitive when we created the VDB? Container here, I'm saying primitive. Primitive is the container, right? So why smoke object we already had? So this is saying, why do we need the smoke object when we have the object where our data is stored? Because that data cannot be simulated, that data can be changed. We need two different types of containers to simulate and to store. So I have wrote, because it was SOP geo, not a DOP simulation state. It was just storing the values. And here the values are like simulating. We are changing the values. We need different types of containers. SOP VDB, initial condition, DOP smoke object, simulation memory. We are storing the data, but these data are different in different form. Smoke solver, okay. Now we have this smoke solver. This is node which tells how the data will change over time. Here we are deciding how the data will change over time. That's it. No need to like have the rocket science about this. Just say how the data will evolve over time. That is dependent on this smoke solver node. I have wrote the same, the thing that updates the value stored in the smoke object every frame. And here the data is evolving every frame. The data is changing every frame. Smoke solver does not create data. It evolved existing data over time. Each frame, the smoke solver, and I have created these nodes because I cannot like I cannot remember these things to tell, because we create, like when I create videos, there is a flow, right? Sometimes I forget to tell you something, sometimes I add extra things, but notes are like necessary. So I don't miss the necessary elements to tell you, right? Each frame, the smoke solver moves density using velocity. Advection, we talked about advection in the when we were creating the clouds, right? Spreads it slightly. Diffusion, I will work with the diffusion, but I guess in the later videos we don't need to understand the diffusion right now. We have a lot to cover. Reduce density, dissipation, updates velocity itself. Like we advect things, we advect particles through velocity. We will see this here. This example we will use. Okay, smoke solver, you understand this? This tells how our value will evolve over time. We have this output. I will talk about this output also, but first, okay, we covered two things. First, our container. To stimulate, we need the container, right, where we can have the simulation. Second, we need a solver that defines how the value will change, value will evolve over time. And we need the data. This is an empty container. We don't have the data, right? But we have the fields. We have the, let's say, rooms to get the data. We have the specific room for specific data. Like for density, we have the density room. We have the volume, let's say temperature room for the temperature data. And this volume source is here to give that data, to import that data from the SOP level. So this volume source here to import the data from the SOP level. And let's create our smoke solver again. Not this, sparse. Object first, smoke solver sparse. Connect this to this, and we have volume source. Connect this to source. We have, let's say, forces, and we have advection. I will cover this, but later we don't need. We need to understand the basics first. If you like force yourself to understand everything, you will like forget most of the things. So learn the basics, keep it slow, right? Keep it slow. Volume source and smoke object sparse. We have the smoke solver sparse. These two are sparse, and I've already talked about sparse, right? We create voxels where we have the values, right? Okay. Volume source. Just see this. Okay, we have volume source. And toggle this on, toggle this on. We see nothing. We see nothing. We see nothing. We see only the container here. This is just an empty container, but this container has different rooms for different type of data, right? Okay. Smoke solver, how the data will evolve over time. Remember this, and we have our data. We have different types of, like, these are ports here. We have forces, we have advection, and we have sourcing. Sourcing is like importing the data, right? Just remember importing the data. We are importing the data from the SOP level. We need a path. We need a path. So let's give this a path. We are smoke simulation, and we have the fog. This I have like given this a name, fog, so we can like differentiate it better. Let's import the data. Now we have our data. Okay, let's run this. What happens? Let's see. We see nothing. And why? We have the data. It is going into the smoke solver. Okay, but we haven't assigned those data to their like rooms. We have the data, we have this data, but we have to give the data to the container, right? We need to put that data into those rooms, into those separate specific rooms. How we can do that? But first, we have this create missing fields. And this create missing fields is important because I will talk about this. Okay, this create missing fields, let's say you have the data coming out from this input is density, and density is density. There is no room for density in this container. There is no room for density. Let's say you don't have a field by name density. So when we don't have a field, like when we don't have a field for a specific volumetric attribute like density, for example density, so we cannot simulate that data because we need the space. First we need the container. This container has to be specific about which type of data it will hold, right? And the data that is coming out from this container should have room for that data. If there is no room in the container for this type of data, we have to create the room. We have to create the field, and this field can be created by this missing field. If the field is missing in this container, then this node can create that specific field for that specific data. But here in this example, we have this smoke object, and this smoke object already has space for this density data, right? We have this density, right? You see this, we have this density, so we have room for density. We don't need to like click this on, so let's just unclick this. Now how we put that data into those specific field? So which data is coming from this SOP node? Let's say you have this volume, and this volume only has density each per voxel. So we have only density now. Operations. First click. Now we have one operation. Operation is the way we put that data into those specific fields. Source volume. What we have? Density. Target field. Room density. So the data that is coming from this fog is going into its target field, which is the same as density. We need to have the space for that specific type of data. Now when I run this, we see nothing because we have to toggle this on. Perhaps SOP, I think this should work. Yes. Okay. You see what's happening here? Now we have our data. And what is happening? What is happening here? What is sourcing? First, what is happening here? What is sourcing? Sourcing is to import, is to source that data from the SOP level. And here, it is sourcing per frame. It is sourcing per frame. So you are putting that data into the container per frame. And we are seeing this. So each frame, we are getting the data, and the smoke is getting thicker and thicker and thicker over time. Right? You understand what I'm saying? The real understanding, the important thing here, what we want to understand here is that this density has to go into the density. What this smoke object do, what this smoke solver do, and how we are changing this smoke solver, we are not changing it right now, but we are seeing this because we are sourcing our imported data again per frame, again and again per frame. We have this, right? We have sourced our data into its target field correctly. And let's first read about solver. The thing that updates the value stored in the smoke object every frame. So it, like, what's the word? Like it sees the value per frame. It visualize the value. It initialize the value per frame. So I can say that we are importing the data. We are evolving, changing the data per frame. Smoke solver does not create data same as the smoke object. It evolves existing data over time. Each frame, the smoke solver moves density using velocity advection, we have talked about this. Filled volumetric attributes stored. See here, create missing fields. Fields only define where data can live. If the field is missing, should I create it? This is just doing the simple thing. If the field is missing, it can create it for you. Volume source copies volume data from SOPs to DOP fields. Example, SOP density to DOP density. DOP density, density field, and it would change or evolve that data over time. Okay, now we have the data. We are importing the data perfectly at each frame. Okay, now we need a force to like move the values. Like we need something, we need some simulation, right? When I connected this, when you connect this a gas access force, just delete this, connect this gas access force. What is doing here? Gas access force like moves the density values in in a particular axis. So just understand this. What I want you to understand here is how this data is getting changed, and how force and velocity is working here. The real thing that I want you to understand here is not about this what is doing here. We need the core here. This gas access force is is applying a force in axis. Just remember this, okay? For now, we have our data. We have our data. This gas axis is applying a force. Force onto what? Force onto these voxels. Just imagine force onto these voxels, and now we are pushing the smoke into onto an axis. And here I want to I want you to understand something here, that the force we are inserting on, on the particles, those particles will get a velocity. These particles have the velocity, and the velocity data is not coming from this volume source. The velocity, we don't have the velocity data from this source, but we have the velocity field on this smoke object. We have the velocity field on this smoke object. So when we apply a force onto these let's say smoke particles, there is no particle. I'm just saying this because we need to understand this, right? So let's say when we apply force and something is in at rest, and we apply force that goes into motion, like velocity, it gains a velocity, right? So we are applying the force, and these smoke particles are getting a velocity. They are getting a velocity, and we don't have the velocity here, but we have the velocity in the container, right? So these values have the velocity. This container has the velocity field, velocity values. We didn't put any velocity data here, but there was data, and that value was 0. The data value in the velocity field was 0, but when we were exerting this force, now we are like giving we are giving the velocity which is non-zero. They have now something. They have velocity, and its value is something. We don't know the value. We don't need to know the value. They are getting a velocity value from this axis force. That's why they are moving in a particular axis. Because something is happening here. They are getting a velocity, and I want to I don't want to import the data at every frame. What we can do, go to here. Activation means 1, we are importing the data per frame, and when we have activation 0, that means we are not importing the data. That's it. Let's go to frame 1. Hold Alt, left click. We have a keyframe. This keyframe says 1, that means we are importing the data. And go to keyframe 5. Let's say 5, and hit again, and it's just give this value 0. So we are not importing the data after 5th frame. So now we are importing the data up to the fifth frame, and after that we are not sourcing the data like again and again. And let's give this a higher force, let's say 10th. We have a strength now. You see it is moving, something is happening. And this node, I want to have the speed. What we can do, we can pump thickness, we don't need global strength. I can increase the global strength so we can have a stronger effect. Just decrease the strength to 1. You can have a better effect when you see this. I need the source. I need some more volume here. What we can do, we can middle mouse, we can like click on this frame, we can wait a second. I want fifth. What is, yes, now I have, now we are sourcing the data up to frame 48, and we are saying this. And strength 1, we can just access force, or we can have the, okay, what I want to tell you here is that now we have the keyframes to import our data, and this gas access force is just inserting a force in a direction, and we are getting a velocity onto that direction. What you can do here, we have this handle for this gas axis, so we are inserting a force. Let's say here you can increase its length. It's just visualization. You can something like this, so it would have a force. You see what is happening here right now? It would like rotate in this way. See what we are seeing here, getting this spiral simulation. See, this is our simulation, this is our first simulation. But here our goal is not to simulate something in this first video. Our goal is to understand these basics first. And I hope you understand what I was trying to tell you here. The sparse object, the smoke sparse, the smoke solver, volume source, gas axis. We don't understand this. We don't need to understand this gas axis. We're just for the example. And this output, we haven't connected the output yet. Output is for the export part. When we export this data to the SOP level, is exporting simulation, not for running displaying the simulation. I will add the PDF in the description, and I want you to read it so you can have a better understanding of this whole concept. I guess this is it for this video, and we have covered the very basics of this DOP simulation. Sorry, and I hope you understand what I was trying to say here. I will see you in the next video, and until then, as always, take care.